Hi everyone, my name is Alexander Montalvo. I am the main leader of this project, which name is Colombia, Precipitation and Temperature Analysis. I'm a current student of Chinese language in Jimmy University here in Xiamen, and also I am an alumni of Universidad del Norte in Colombia. This project, I made it with two other colleagues, which names are Elena Cisneros and César Muñoz, also from Universidad del Norte, and our main instructor was the Professor Humberto Avila, also from the Universidad del Norte, which is a lecturer in water resources engineering. This content of the project is like main focus of data sources and processing that we did. First, the Python script from where we concatenate all the raw data. Then the data analysis that we did part in Python and the main part in Supermap. After that, just gonna be like Superman discussion products, and by the end, the map description. The description. So the main data sources at the beginning were first, more of them CSV data from Rainfall monthly station from IDEAM. IDEAM is the Colombian main government for acquire and measure environmental data. The data that we have was basically CSV files that we concatenate, and then the rest of data was for precipitation and temperature from Cooler Engine through a library for local machine called GMAP. The main products from here was like raster data, just representing temperature and precipitation with a scale of 5 kilometers per pixel. After we have all these data sources, we make the data processing. First in Python, mainly for data concatenation, because all the EDM data were different CSV files from different stations. In total, we had 427 stations, each one 1 week, one record per month across different years. We concatenate that, then we clean the data. For example, just taking the columns that we have, and in the data preparation report, there is more explanation about this. And then we did the primary analysis. For example, have how many missing records have each data, each station, and also the main product to vectorization of the bivariate class mapping that we're going to explain later. On Supermap, we did spatial aggregations for mainly mapping using. We configured the styles. We made the geodatabases. We also got ISO regions based on the raster data. And at the end, we also performed vectorization. The main products were or are in the folder project in the project folder. Had a geodatabase with raster data about the precipitation, then a big geodatabase with different type of data, polygons, just attribute data, shape files, and then the final mapping. So for the data processing, it's gonna be two steps, mainly two steps. The first one was all the CSV files like we downloaded from IDEAM. Those are kind of like the different records for each station. The stations were got in here where you can see the data aggregation. It was one of the main products of we process with IDEAM. So in total were 427 stations, each one with different different length on the data sources. And we also stack from ggmap the precipitation and the temperature. Here is one example of the ISO regions that we did.
Hello, and next I'm going to explain the data cleaning and missing records analysis for this project. First, the missing records refer to data that is expected but not provided by the stations. In other words, this is the main idea for this project because some stations don't give a complete information for rainfall characteristics of hydrology, Colombian hydrology. Uh, the main process was to collect data from missing rain station and use with information for database. Uh, the database content to some folders, and these folders organized per department have characteristics like precipitation variable per department, and these contribute data about missing gauges in a platform. Uh, Later, a maximum of 10 stations per department is selected, prioritizing the oldest seasons and monthly precipitation as the main variable. This information is then downloaded and from the IDM platform. Finally, calculate the mission records. The downloaded data is grouped. Then compare the expected and available records to determine the missing data percentages. In this presentation, have to graph that compare the percentages missing record with Colombian departments. And in this graph, show to Caldo's department with the higher missing records. And while Casanare and Guainía departments don't have missing records.
Hello, now I'm going to explain the rainfall monthly analysis that we did for this project. Well, first, we use a global dataset that provides us with high resolution precipitation estimates. This was CHIRPS. The data here is organized in a 5-day period, and we call that a pentant. And to calculate the multi-annual monthly mean of precipitation, we first selected the chirp and we filtered it for the specific year and month that we wanted to study. And as you know, the data is reported in a 5-day interval, so we group the necessary pentons to cover a full month. Typically, this required about 6 pentons for each month. And then we sum the precipitation values for all the pentons in each month to get the total monthly precipitation. And after gathering monthly totals for several years, we calculated the mean precipitation for each one of the months. And this is basically the multi-annual monthly average. And now we got like a general information, but to better visualize the results, we use isoheights. As you can see here in this slide, this is the Colombian map with isoheights. And why? Well, the isoheights, first, what are isoheights? Are lines that connect in a map points with equal precipitation. And they are really useful to see how the precipitation, the rainfall, is distributed across the different regions. So first we selected the grid of the Colombian map, and then we interpolate and get the isoheights.
And one of the main products was also this mosaic composite showing the multi-annual monthly isoregions precipitation from January to December in Colombia, where you can see, for example, during the months of between March and June, there is a clearly more rainfall, right, in the eastern region. But then, like the dry seasons, we can see is clearly between November, December, and January from almost all the country, except for the Pacific region in this side. For this process, we basically made a model builder for made iso regions in Supermap, where from the raw data, that is the rainfall that we download through Google Earth Engine, we first vectorize, like extract the ISO region, right? And then we clip with the boundaries of Colombia that we had. And in this clip, we basically make the summary of all of these ones. The stack that I talked about before was an image collection that we obtained and we process in Python. And then the final representative raster dataset with the means was the main product from where we start this process that I highlight here from obtain the ISO regions. The main product that we had was the bivariate mapping that I'm gonna show you after at the in the last slide. Basically, we have the mean temperature raster, the mean precipitation raster across the year without have any type of grouping. We clip with the administration level 0 of Colombia, and then in Python, we basically made a point cloud classification of the different type of cloud distribution that we had for each one of these variables, one for the temperature and one for the precipitation. That histogram is the one that you can see here, where we took 16 classes of the histogram that are the 16 boxes that you can references here in this legend. So one of the main products that we had is like across all those years from the beginning of the 90s till 2023. We have like the mean temperature was 1.42, the maximum was 28, almost 30, and for the precipitation was from 0. In Colombia we have like a different variation of climate till almost 610 millimeters. We also did diagrams inside the Supermap, taking just the attribute data that didn't have any attribute spatial data, but that have like for the code of the station that we downloaded. So that attribute, the code of the station, play the key role of, in case that we need to join with, for example, boundaries, we had that as the main distribution. So here you can see the anomaly. We analyze the ENSO, the El Niño, which is kind of like the one of the microclimatic phenomenon that affects Colombia. And we see here that mainly more than 60% of the anomalies that we had varies between minus 20 till 8. Also, we can see here like how many stations and each station, how many records it has by administration level. In Colombia, we call departments. So we can see like Meta, Cesar, and Bolivar, which are not in the central region of Colombia, but the central region in Colombia is the one who has more stations. Interestingly, are the ones who have more records. And then the main reason that we use the raster data is because if you see here, the top 3 with less records are the ones located near the Amazon and the eastern plains of Colombia. So here is the final map description, the final map result. You can see first the distribution of the station that we had. Here in the middle is where I said that where most stations were located, but this is not where more records are. This is because mainly maybe in the other regions the stations that we download from the EDM network has or are older than the ones that were installed in the central region. Here you can see like the different patterns, right? Where it comes from low temperature and high precipitation in specific areas. For example, the Sierra Nevada Santa Marta, which is like in an arid region like this one, is like a really peak in the elevation. And finally, you can see also a mosaic that I showed before that was constructed by a mean-only data. Finally, this is the references that we took for analyze all the data from the data processing till the end. Any further comments, you can find it on the report and on the data description analysis.